In this video, we are going to be learning how to subtract integers. Again, you'll be needing your number lines, your counters, and then we're going to be showing you a third method where you rewrite the problem as addition. Okay, so in our first example, we have 3 minus 6. So notice how we have both positive integers, but this time we're going to be crossing over that zero threshold and going into the negative values. So we'll go ahead and mark these. So here we have two positive numbers. Okay, and we are going to be starting at 3 on our number line. So here we go, we're starting at 3, and we are taking away 6. So we're subtracting 6. Now, just like you would with a regular positive minus a positive, if you are subtracting a positive, you are going to be moving to the left on your number line. So I'm going to move 6 integers to the left. So 1, 2, 3, 4, 5, 6. And notice how I've crossed over 0 and I'm left with negative 3. And so negative 3. And imagine this is a scenario like you have $3, but you owe someone $6. How much money do you have? And it would be you are in debt $3. Or maybe it's 3 degrees out and the temperature dropped 6 degrees. What is the temperature now? It's negative 3 degrees. So we're going to go ahead and mark our number line. So we're starting at that 3. And we've just hopped down 6 steps. 1, 2, 3, 4, 5, 6. And we'll go ahead and draw that there. So we landed at negative 3. Okay, we can also model this problem using our integer counters or integer chips. Okay, so we're starting with 3 integer chips. So let me move this to the side. Here we have 1, 2, 3. Okay, so let me just draw that. 1, 2, and 3. Now, I need to take away 6. So I need to remove 6 positive integers. But as you can see, I don't have 6 positive integers to remove. I only have 3. So in order to take away 6, I actually need 3 more positives. But I don't want to change the value of what I have here. We still want it to represent the number 3. So think back to the last video of what we did with the idea of 0 pairs, meaning if I have a negative integer and I have a positive integer, those two cancel each other out and make a 0. So if I want to take away 6 integers or 6 positive integers, I can add in or represent a few extra sets of 0 pairs. And now I have enough integers to take away. So I have the 3 that I started with, and then I added 1, 2, 3 sets of 0 pairs. But notice, these cancel each other out. They're equal to 0. And so I still have only 3. All right, so if I now take away those positive 6, 1, 2, 3, 4, 5, and 6, what am I left with? 1, 2, 3 negatives. So 3 minus 6 is going to be negative 3. And I can show that with my diagrams here. So I'm going to add in those 3 sets of 0 pairs. And I'm going to add a note here at the bottom. I can add in 0 pairs without, that stands for without, changing the value. And you can add in as many 0 pairs as you need in order to make enough to take away. So to show that I took those away or I subtracted them, I'm going to cross them out. 1, 2, 3, 4, 5, and 6. And then what am I left with? Those 3 negatives. Okay, so the third method I want to show you here is rewriting this problem as addition. Okay, so if I want to take away 6 positives from 3 positives, it's actually equivalent to the problem 3 plus a negative 6. Okay, so if I have a positive 3 and I'm adding 6 negatives, 1, 2, 3, 4, 5, and 6, I get 1, 2, 3 sets of 0 pairs, and then I have negative 3 extra. So these all cancel each other out, and then I'm left with negative 3. Okay, so I'm going to show that there, and I'm going to show that there. So what you can do with any subtraction problem is you can change subtraction to addition and change the sign of the second integer. Okay, so let me repeat that. Your first integer stays the same. 3 remains 3. Subtraction becomes addition, and your positive 6 becomes a negative 6. And so now you can do this, you'll have the same outcome, but you won't have to add on these 0 pairs. So you are just taking your positive 3 and you are adding 6 negatives, and those are going to be equivalent.